thank you again, everybody, for joining us. And for those of you who are watching the recording, we appreciate you catching us on demand. You can see Matt Anderson and myself, Shelly Avery, are going to be your hosts today. We are excited to kick off a new webinar series that we have. We used OpenAI to come up with our naming and all of our graphics for this series. And so it was a lot of fun coming up with fun names and graphics. So Intelligent App Chronicles for Healthcare. For this first inaugural session, we have Tim Ferro, who's a senior Azure Technical Specialist, joining us today, talking about containers in Azure, where to run them, what are all your options, and how to use them to accelerate innovation in healthcare. So before we get started, just a couple of housekeeping items. This is a regular Teams meeting, but we've engaged some of our webinar and moderator controls. So you'll note that you are all muted and your camera is disabled. We do that because we hope we get hundreds and hundreds of people joining us, and that we want to control the excitement for interrupting our presenters. But we do encourage you to ask questions. The chat is wide open, and we encourage you to use the chat to engage with us and with your peers across the health and life sciences industry. Towards the end, we would like to open up the mics for live questions. So when we do that, please just use the raise the hand feature, and we'll make sure to bring you off mute and you can talk live with our presenters. These are also being recorded. We will post the recording after the session. So if you loved it or you missed one, you can always catch it on demand. So now let's do one interactive thing here. We would love for everyone to practice. Go over to the chat and let us know where you're coming from. If maybe the city or state or company that you represent, we would love to engage with you. All right, so we are going to head on to the presentation. Again, I want to just take a minute to introduce our speaker today, Tim Ferro. Thank you so much for joining us, and we are excited to hear your content around containers in Azure and how that helps with innovation in healthcare.
Awesome, thank you. Let me make sure, I'm trying to share my screen. Can you all see my screen okay?
Got the screen,
yes.
You're good to go, Tim.
Awesome, so I'm gonna have the presentation up on one screen, and I'm going to try to monitor the other screen for notes and questions in the chat. Again, if we could use the functions over there, we'll try to do live questions at the end, but during this, please feel free to put them in the chat. If I see them, great, and if I miss it for whatever reason, they'll bookmark it, and we'll go back at the end of the presentation. So let me just get set up and kick that off. So again, thank you for all being here, and thank you to everyone who's watching this later. This presentation is where to run containers in Azure. Tim Ferro, I'm a senior Azure Technical Specialist at Microsoft. Today, I'm going to go over a number of things. First, just to level set, I'm going to go over the benefits of using containers pretty quickly. I hope everyone here is familiar with it, and that's why you're here, but just level set for the purposes of today's call. And then I'll talk a little bit about Kubernetes and Azure, around Kubernetes itself, and then Azure, and then we'll talk about the Azure services that can run containers. And then lastly, we'll go through how to decide, right? I'll talk a little bit about some comparisons between different services and a decision kind of tree that I can share to help walk you through that and figure it out. So first, again, want to go over the benefits of using containers. So just level set again, what is a container, right? A standard package of software known as a container bundles an application's code together with the related configuration files and libraries and with the dependencies required to run them, right? So why do we care, right? What is that? What does that get us? And the problem we're trying to solve is that an application that fails to run correctly when it's moved from one environment to another, really that problem is as old as software development itself, right? These problems usually arise due to differences in configuration or underlying library requirements or other dependencies, right? And containers address this problem. They provide a lightweight and immutable infrastructure for application packaging and deployment, right? So an application or service, its dependencies and its configuration are packaged together as a container image, and the containerized application can be tested as a unit and deployed as an image instance, right? So this way, containers enable developers and the IT professionals to deploy applications across environments, right, with little to no modification, right? So that's the big benefit is right there. That's why we're having this discussion. That's why we're on the call. That's the reason that we have this. So then what are the benefits of running containers on Azure, right? There's lots. First is flexibility, right? The ability to deploy containerized applications in your preferred environment, which is really what this presentation is mostly about. We're going to discuss many of these options in just a couple of slides, so I'll get back to that. But also productivity, right? We can accelerate our containerized application development. We can automatically build and containerize and scaffold any applications, either directly from the IDE, or we could use full CI/CD pipelines with DevSecOps, auto build and push to a secure container registry. We can rapidly iterate, test, and debug microservices. We can leverage the built-in monitoring and logging to get full visibility of container health and app telemetry, right? So there's a lot of productivity gains for running your containers in Azure. The other is trust. And you can efficiently manage your containers with Azure Container Registry, get a full view of your container deployment, view centralized CPU, memory, storage, network, and performance information with tools like Azure Monitor or App Insights or Log Analytics, and then provide full stack security for containers, including vulnerability scanning or runtime protection and compliance. And speaking of compliance, you can look up all of the services that we're going to discuss today in the Compliance Center to see what compliance certifications are there and follow up if you have any questions around that. So when we talk containers, most of the time people think AKS and Kubernetes, right? So there's two parts to this. The first is what is Kubernetes, and then how do we leverage that in Azure? But I want to level set on Kubernetes quick. So before we get to all the other options, Kubernetes itself is an open source software for deploying and managing containers at scale, right? So keeping containerized apps up and running can be complex, and it often involves many containers deployed across different areas, and Kubernetes provides a way to schedule and deploy those, right? So plus, you can scale them to your desired state, manage their life cycles, and you can use it to implement your container-based applications in what we call a portable, scalable, and extensible way. And that's Kubernetes itself. That's a lot of what we all think of. A lot of times when we think of containers, we think of Kubernetes, and then usually we also think of, okay, well, how do I do that on Azure? So you can build and run modern, like I said, modern portable microservices applications using Kubernetes to orchestrate and manage the availability of the app components. And Kubernetes supports both stateless and stateful applications as your teams progress through the adoptions of microservices. So as you can see here, right, Kubernetes on Azure is enterprise grade, and that's by design. You can run AKS, Azure Kubernetes Service. You can run Azure Red Hat OpenShift, and we have a full platform supporting this. So we can talk more about this as I get to the AKS and the ARO, Azure Red Hat OpenShift part of the presentation, but I just wanted to see, usually again, when we think of containers, this is the part that we think of, and there's just a lot to this ecosystem that we wanted to highlight. But let me move on probably to the slide that most people were thinking would be here when we have this kind of this type of presentation, right? So containers on Azure, right? What are our options? This is kind of a quick reference to 10 different ways that you can run containers on Azure. There are more, but these are the 10 ones that get discussed most often. And I'm not going to go through each one of these on here because I will go through every one of these following this slide. But I just want to kind of give everyone a visual. Like, hey, these are the main areas when we're talking containers on Azure. What are my options? What am I deciding between? How do I decide between? And oh, I didn't know, right? So sometimes people don't know that you can run containers in all of these, right? So I wanted to make sure just to kind of level set again, what are the services we're going to be discussing and where you can run them. The only one I'm not going to dive into deeper as we go through is Azure VMs, right? So if you need full control, if you want to build Kubernetes yourself from the ground up, or if you just want to run it via Docker or something like that, you can run containers in VMs. So no problem with that at all. But we're going to be looking at the other 9 options here. And then, like I said, we're also going to look at a couple places to store them, some options for securing them. And then we'll come back around at the end, show you the kind of decision tree that's out there in the Microsoft documentation, as well as kind of how to walk through that, and then some comparisons of different services. I'm just going to take a second here to look at the chat and make sure I'm not missing anything. Okay. So let me move up to the first one. I'm going to kind of, like I said, go through these, talk about each one, let you know what they are to kind of level set, and then we'll come back around and do more of a comparison later. But some of this is also around how, hey, I didn't know we could run containers here. Yeah, here's how you can do that. Let me talk about it. But first, again, the one that is most likely to be talked about, Azure Kubernetes Service, AKS. This simplifies deploying a managed Kubernetes cluster in Azure and offloads the operational overhead to Azure, right? So as a hosted Kubernetes service, Azure handles critical tasks like health monitoring and maintenance. And when you create an AKS cluster, a control plane is automatically created and configured. This control plane is provided at no cost. As a managed Azure resource, it's abstracted away from the users, and you only pay for and manage the nodes that are attached to the AKS cluster. AKS offers the quickest way to start developing and deploying cloud-native apps in Azure or data centers, or even at the edge. You get unified management and governance for on-prem, at the edge, multi-cloud, Kubernetes clusters, and interoperate with all of the other things in Azure that's important to you, like security, identity, even cost management and migration services and things like that. So just to reiterate, when you think about AKS, it's 2 parts. It's one is that it's the managed Kubernetes service that's very beneficial to leverage. And the other part is that you get interaction on the previous slide with the rest of the Azure ecosystem, right? You're fully built in, and also some of the open source ecosystem that was there. And this is for orchestrating microservices at scale. You need scale up, scale down, microservices that interact and talk with each other, things like that. So again, as you're thinking through your use cases of what you have, think about as I go through these, oh, well, maybe it would fit in this, maybe that would be a good fit, right? That's a good place to start as you go through these, this kind of exercise to figuring out the best place for you to put your containers. So next is Azure Container Instances. And ACI offers the fastest and simplest way to run a container in Azure without having to manage any virtual machines or without having to adopt any higher level service, right? So Azure Container Instances is a great solution for a scenario that can operate in isolated containers, right? So simple applications or task automation and build jobs, things like that. For scenarios where you would need a full container orchestration or service discovery, automatic scaling, things like that, we would recommend AKS as another option, right? And so speaking of AKS, though, to rapidly scale application workloads in AKS, you can actually use virtual nodes, and virtual nodes have a quick provisioning of pods, and you pay per second for their execution time. You don't need to wait for Kubernetes to auto scale to deploy VMs. the nodes are pods. Note virtual nodes are only supported for Linux pods and nodes, but virtual nodes enable, what they do is they enable network communication between pods that run in ACI and the AKS cluster. And to support this, virtual network subnet is created and delegated permissions are assigned. So what's that mean? That means that you can have your AKS cluster and you can have your auto scaling set up, but you can also what we call burst to ACI. So if there is an extreme level of network traffic coming in or users using your service, you can have ACI set up to spin up extra, we'll say web front ends in order to service the influx of demand. And then your AKS cluster can still scale up in the background in order to get to the right level. And then you can scale down your ACI and have that then meet the demand. So a really cool feature is bursting to ACI from AKS. So I wanted to highlight that. That's why I have ACI next in the flow of this, right? So AKS and think ACI if needed for those real high level or huge influx. So next is Service Fabric. So Azure Service Fabric is a distributed systems platform that makes it easy to package, deploy, and manage scalable and reliable microservices and containers. So Service Fabric addresses the significant challenge in developing and managing cloud-native applications, right? So a key differentiator of Service Fabric is its focus on building stateful services. And you can use Service Fabric programming model or run containerized stateful services written in any language or code. And you can create Service Fabric clusters anywhere, including Windows Server and Linux on-prem, other public clouds, anywhere, Azure or not, right? So Service Fabric is another option for running containers, stateful services, and kind of orchestrating that all together. Another one that I've seen come up a number of times at different places is actually Azure App Service, right? So App Service itself is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. And you can develop in your favorite language, be it .NET, .NET Core, Java, Node.js, PHP, Python, whatever. And applications run and scale with ease for Windows and Linux environments, right? So that's Azure App Service itself. But also, you could containerize your app and host a custom Windows or Linux containers in App Service. So when we're talking App Service, we're really focusing on websites, REST APIs that support them, mobile backends, and you can either deploy directly to it. So say you've got a .NET Core web app and an API that supports it, you can deploy that directly, code directly onto that, or you can containerize it and deploy that container to App Service. So really versatile in what it can run. I also find it's a nice stepping stone. If say you're thinking or you're getting into containers and you're not sure where you're going to run them, this is something where you can put your code out and then you can containerize it and put it out and really double check it, making sure it's running the same way. And then you can decide, do I need to move to something else like Azure Container Apps, or does App Service get me what I need, right? Am I really more focusing on the website, or am I focusing on something else? Do I want to pull apart this app a bit, do microservices architecture more, and then, okay, let me move to AKS. And then I can still host something in the front end if I want, especially if it's an app, or maybe I'll move the whole thing over there. So just a really nice service that can run either. And it's great to consider when you're looking at this. Next is Azure Batch. So you can use Azure Batch to run large scale, parallel, and high performance compute batch jobs efficiently in Azure, right? So Azure Batch creates and manages a pool of compute nodes, think virtual machines. It installs the applications you want to run and it schedules jobs to run on those nodes. And there's no cluster or job scheduler software to run or install, to manage or scale or anything like that. Instead, you use batch APIs and tools and command line scripts or the Azure portal to configure and manage and monitor the jobs that you have, right? But batch jobs can run directly in VMs in a batch pool, but you can also set up a batch pool to run tasks in Docker compatible containers on the node. So containers provide an easy way to run batch tasks without having to manage the environment and dependencies to run your applications. And container-based tasks in batch can also take advantage of features of non-container-based tasks, including application packages and management of resources and files and output files and things like that, right? So batch is for, again, parallel, repetitive compute jobs, and you can either give it, you can set it up without, or you can have it with containers, which is a really nice thing that you can leverage for doing that type of work, especially if it's high performance compute, or you just need this parallel batch job and you already have a container. It makes it easier to do those types of things. Let's talk about Red Hat OpenShift here. So the Microsoft Azure Red Hat OpenShift service enables you to deploy fully managed OpenShift clusters, right? So Azure Red Hat OpenShift extends Kubernetes, right? So it combines lots of the things that you need to do, like setting up integration with middleware or using frameworks or doing, databases and CI/CD tools, right? It's a single platform, right? Think about it like that, and it brings the ease of operations to IT teams while giving application teams, what they need to execute. The key is that Azure Red Hat OpenShift is jointly engineered, operated, and supported by Red Hat and Microsoft to provide an integrated support experience. There's no VMs to operate, no patching is required. All of the nodes, be it the infrastructure or application nodes, are patched and updated and monitored on your behalf by Red Hat and Microsoft, right? So if you're running OpenShift on-prem, this is a great option for coming in. If you want to extend Kubernetes, but you want to go this route, you can. Your other option is obviously to go to AKS. So two great options for having a managed Kubernetes instance in Azure instead of having to run it all on your own. Another one that I think doesn't come up enough where you can run containers is Azure Functions. So Azure Functions itself is a serverless solution, allows you to write less code, maintain less infrastructure, save on costs. Instead of worrying about deploying and maintaining the servers, the cloud infrastructure provides up-to-date resources needed to keep your apps running. If you want, complete control over your functions runtime environment, you can even deploy your functions in containers that you can customize. So your custom containers can be hosted by functions or deployed as part of microservices architecture to, say, Azure Container Apps or even to AKS or Kubernetes, right? So you can either deploy directly to functions, just put your code in the cloud, let it run, great. Or you can actually containerize the functions runtime, and you can run that in Azure Functions as well, in all of the plans except for the consumption plan. Any other plan, you can do that. Or you could take that function after it's containerized and run it in another service and leverage it there. So like, especially if you have microservices and you want to add on other functionality, you could say containerize a function and put that into your AKS cluster as well, and then have that do what it does there. So interesting option depending on what you're trying to do or what you need. So you don't need full orchestration. You could run it here. All right, so Azure Container App, right? This is one of the newer offerings that's come out. Azure Container Apps, for those that may not be aware, is a fully managed, we'll say Kubernetes-based application platform, right? It's not Kubernetes to you, it's Kubernetes-based. And it helps you deploy your apps from code or containers without orchestrating complex infrastructure, right? So you can build modern apps or microservices with unified, centralized networking, observability, dynamic scaling, configuration for higher productivity, things like that, right? So you can design microservices with full Dapper support, so that's distributed application runtime, and you can do dynamic scaling powered by Kata, which is Kubernetes event-driven autoscaler. Right, so think container apps. Think of it as a level up from Kubernetes. If you're thinking, oh, I don't know which one I need, there's a number of decision points that you can make here. You say, oh, I need full access to, let's say, the Kubernetes API because I make those types of calls, or I need to do things through the Kubernetes API and control plane, then you might be looking that way. If you don't, if you just say, hey, I like containerized apps, I like microservices, I want to deploy some APIs, I got some background jobs that are running, I want to do event-driven processing, right? So, Azure Container Apps, integrates naturally with Kata and Dapper and Envoy, all things that you would want to run that you can set up in AKS, or you can run here. And you could say, oh, maybe I'll start here and go to AKS if needed. So it's just another option and decision point. But I want to dive into this a little bit more, right? So Container Apps enables executing application code packaged in a container, and it's unopinionated about runtime or programming model, right? So with container apps, you get the benefits of running containers while leaving behind the concerns of managing, complex orchestrators and cloud infrastructure. So we recommend maximizing productivity with a serverless container service built for microservices. If you look here, these are 4 of the main examples of scenarios for running an Azure Container App. So first, public API endpoints, right? This is having traffic run to a public API. You can do revisions, you can do traffic splitting, and you can even scale based on the number of concurrent HTTP requests, right? And it's built into ACA, which is really nice. You can also use this for background processing. So it's a background job that, in this example, transforms data in a database. This can be triggered by a schedule. It can be run on demand. It can be based on other events. There's also event-driven processing. So there's a queue reader. We'll say, oh, our application runs off of a queue and processes messages, right? And we can scale based on, say, the number of messages in the queue. And last is microservices, right? So if you are going down the microservices route, hey, we have that in here. You can have them be deployed. You can have them do service discovery, you can use Dapper, and you can still scale and trigger by any of the triggers in Kata as well. So a lot of options here. And it's a great place to start. If you're unfamiliar with this, highly recommend leaning in, looking at what you get here, deciding, oh, is this the right place to start for me, based on what I'm trying to do. So another spot that I want to talk about before getting to the storage areas is IoT Edge. So this is really key. IoT Edge is a device-focused runtime that enables you to deploy, run, and monitor containerized Linux workloads, right? So analytics drives a lot of business value in IoT solutions, but not all the analytics needs to be run in the cloud. So IoT Edge helps you bring that analytical power of the cloud closer to your devices to drive better business insights and enable, we'll say, offline decision making, right? So for example, you can run like anomaly detection workloads at the edge and respond as quickly as possible to any emergencies on a production line. Just as an example, right? And if you want to reduce bandwidth costs of transferring, terabytes of data to the cloud to do your analytics, you can clean, aggregate, and then only send, the insights to the cloud for analysis, and capture it out at the edge, run your container at the edge, look through your data at the edge, and then only send back what you want, right? Just to note, IoT Edge is a feature of IoT Hub, and it enables you to scale out and manage an IoT solution from the cloud. You can package your business logic into standard containers or use pre-built IoT Edge modules from the Azure Marketplace. IoT Edge modules, they're just containers that run in Azure services. You can also have third-party services or your own code. Again, they execute on the devices at the edge. So where are we going to store these containers? So we've gone through, I think, the top 9 places. Let's say top 9. We've gone through 9 places of where to run our containers, but we also need to think about where are we storing them, how are we securing them, and then we'll come back again to how to decide. But Azure Container Registry, really cool, a lot of great features. I'm going to highlight a couple, right? So it's a managed registry service based on the open source Docker Registry 2.0. You can create and maintain Azure Container Registries to store and manage your images and the related artifacts, right? So you would use Azure Container Registries with your existing container development and deployment pipelines. Or you can use Azure Container Registry Task to build container images in Azure. So you can build on demand, you can automate with triggers such as source controlled commits or base image updates. So let me highlight that, right? Azure Container Registry, you can use one of the tasks to build an update when another base image is updated. So when there's an update somewhere else, you'll see it, trigger it, pull that image in. So a lot of times this is for base images that are from other areas that you then bring in and layer your security scans and software updates on top of before you provide that internally to your development teams. So you say, oh, this external base image, you'll say the Microsoft Windows, one of the Windows server base images. Awesome. There was an update there. Pull it in, layer your stuff on top, rerun your scans, and provide that image to your internal teams. So really cool feature that it can automate that. The other one I want to highlight is that companies, they want a local presence or a hot backup, right? So in many regions. So they would run in multiple regions. And as a best practice, it would be place a container registry in each region where your images are run. So it allows closer network operations to pull it across. It just makes it faster and easier rather than pulling from one ACR globally. But there's a feature, and it's geo-replication. And geo-replication enables an Azure Container Registry to function like a single registry, but serves multiple regions with multiple primary regional registries, right? So that way you let ACR be the global distribution for your containers. And then it is local in those areas to pull in. So if you're running multiple AKS clusters or multiple instances of Azure Container Apps, let ACR pull those to that region, and then that way you can do your deployment from the closest region there. Sorry. GitHub as well has a container registry, which is really cool. So this container registry stores container images with your org or your personal account, and it allows you to associate the image with a repository. You can choose whether to inherit permissions from the repo, or you can set granular permissions. You can also access public container images anonymously. So just want to let everyone know, ACR is one option. GitHub has a container registry as well. And then lastly, before we get into kind of the decision-making part of this is I want to mention Microsoft Defender for Containers. And that's a cloud-native solution to improve, monitor, and maintain the security of your clusters, the containers, and the apps, right? Defender for Containers assists you with 4 core aspects of container security that I want to point out. 1, environment hardening. So Defender for Containers protects your Kubernetes clusters, whether they're running in AKS, on-prem, if you run it yourself, even in Amazon EKS. Defender for Containers will continuously assess clusters to provide visibility into things like misconfigurations and guidelines to help mitigate identified threats. The second, vulnerability assessment. There are tools for vulnerability assessments and management of images that are stored in Azure Container Registry or in Elastic Container Registry. 3 is a runtime threat protection for nodes and clusters. So threat protection for clusters and nodes generates security alerts for suspicious activities. And 4, agentless discovery for Kubernetes. And that provides tools that gives you visibility into your data plane components, generating security insights based on your Kubernetes and environment configuration, and lets you hunt for any specific risks that you're looking for. So really great. And this goes back to, as I talked at the beginning, why run containers in Azure? Where can you run them? Why would you run them there? Just these other integration features that we have to help you keep them running and secure. All right. So now, how do we choose? So if you have gone out and you've searched on the internet for how to pick either an Azure service or how to choose where to run your containers, a lot of times you're going to end up on a website from Microsoft that has this image on it. And I want to highlight this because this is a really great reference to help you make a decision, or at least get you in the right starting point. If there are some questions that kind of lead you one way, great. If you get through the whole list, and I'll walk through it in a minute, it may take you another way, but at least gives you a good idea. And this even points out, what is a container exclusive service? What is a container compatible service? And this is for anything. So taking a step back, choosing where to run things in Azure obviously there's a lot of places that you can do this. And this is just a high level walkthrough, but it does lean towards containers here, which I think is why it's a great starting point for us. This diagram specifically, though, it talks about two migration strategies. One, lift and shift, right? And that's just for migrating a workload to the cloud without redesigning the application or making code changes. We call that rehosting, right? And that's an option. It says it on the upper left. The other one, though, is cloud optimized. And that's a strategy for migrating to the cloud, refactoring applications to take advantage of cloud native features and capabilities. The referenced article also includes several tables that can help you choose a service. So it's really cool. So again, go to this page. We can put the link in the chat. If someone else can put it in, great. If not, I'll drop it in at the end of the talk. Go here at least to start, get a good idea, check out the reference tables. But I'm going to walk through this kind of how I read this when I'm trying to decide, right? So assuming I'm not migrating something, that's lift and shift, because that's going to take you right down the path on the left side and say, hey, it's probably one of these options. But even if I am lifting and shifting, but can I be containerized? Well, then that'll bring me back over to the right-hand side, right? Or if I'm building it new, obviously I'm going to go to the right-hand side. I'm going to think about what my options are in Azure. And we'll look, right? Do you need, these are like the high level questions that you're going to need to ask yourself that kind of point you to one thing. And I get it. There's a bunch of different questions that you need to ask yourself, and I'm going to walk through that next. But these are the high level ones, right? Do I need full control? We're looking at VMs. Is this a high performance compute workload? Probably looking at Azure Batch. Is this going to be a Spring Boot apps application? Looking at Azure Spring Apps. Is this more event driven and it's more shorter lived? Okay, we're looking at Azure Functions. Is this going to be a website, right? Is this a web hosting platform of features with APIs that aren't necessarily a microservices architecture, but that are used in a website? Or is it the backend for a mobile app? Great, we've got app service. And then we get down to the next one, right? Do we need full-fledged orchestration of our containers, right? So if it's no, we can look at Azure Container Instances. I would also say that you could also look, if you need it running constantly, look back up at Azure App Services here or Azure Container Instances. Well, do you need full-fledged orchestration in some way, shape, or form? If it's yes, then we're going to come over to the left. Now, do you need a managed service or not? So meaning, do you need something like AKS or ARO or Service Fabric? Then we're going to come right back over to that area. If you don't, then you're saying, oh, I don't need a managed service. I'm going to run my own. Either I'm going to run Kubernetes myself. I'm going to run OpenShift and VMs, things like that. But we say, hey, in Azure, we're going to take advantage of those features. So we'll come back over and we'll say, hey, is this an older .NET Framework thing? Are you familiar already with Service Fabric? Cool, we can use that. Is this already on Red Hat on-prem, or are we familiar with OpenShift? Great, we've got ARO. Do we want to get into all of the ecosystem and everything you get with Kubernetes from an Azure perspective? Say, okay, you got AKS, and it says right here, do you need access to the Kubernetes API? Meaning, do we need to build our deployments and specify, lots of things and bells and whistles and all of the stuff that goes into Kubernetes, even at a managed service perspective? It's absolutely fantastic for that. And you use, kube control and the Kubernetes API to do a lot of that. And if you don't, if you just need similar things, so like we said, Kubernetes-like service, then we're saying, okay, well, what about container apps, right? So it's kind of how you end up there. Again, lots of other things to consider, but this is just a high-level thought process that you can go to when you're trying to at least find a starting point. Again, this isn't the absolutely you walked your way through, you answered your questions, you came to the end and went, yep, this is what we're going to do. Because then you're going to want to look at all of the comparison of similar things, right? ARO versus AKS, or container apps versus AKS, or things like that. So on the page that you would find this, and I think that someone put this in the chat already, so thank you. On that page, which is in the Azure Architecture Center. If you scroll down a little bit more on the left, there's actually a link to an article for comparing container options. So after you kind of get through this, you think, okay, how do I really compare these? If you click on that link, it actually takes you to the Azure Container Apps article on the Microsoft Learn site. And it kind of walks you through a comparison between container apps and a number of these options. So I'm going to walk through that a little bit now because it has a number. It starts pointing out comparison things versus earlier. That was a lot of just level setting. Hey, this is an option to run a container, and this is what the service is. Also, did you know you can run a container on it? Got it. Now it's okay. Well, how do I choose? What is one better at than another? And I touched on that a little bit, but let me walk through this. So, and it starts with, what does container apps do? What is it good for? What scenarios is it good for, right? So it says container apps enables you to build serverless microservices and jobs based on containers, distinctive features for container apps, right? It's optimized for running general purpose containers, especially for apps that span, microservices that are deployed. It's powered by Kubernetes and open source technologies like Dapper and Kata and Envoy, supports Kubernetes style apps and microservices, with features like service discovery and traffic splitting. It enables event-driven application architecture by supporting scale based on traffic and pulling from sources like queues. It also includes scale to zero. So one of the features of Azure Container Apps is that it can scale to 0, which is a really nice feature. And again, it also supports running on demand or scheduled or event-driven jobs, right? So you can have your container run on demand in ACA, spin up, do what it's doing, spin down. Again, to note, Azure Container Apps doesn't provide direct access to the underlying Kubernetes API. So if you need that, then you should look back to AKS. However, if you want to build an app in the style that you would put out for Kubernetes, but you don't need the native Kubernetes API or cluster management, this is a really great fit, and you should start looking there. So that's kind of your ACA versus AKS decision and discussion points. App Service, again, that provides a fully managed hosting for web applications. It includes websites, web APIs. Web apps can be deployed using code or containers, and obviously we're talking about containers for this. It's optimized for web applications, and it's integrated with lots of other Azure services, right? So again, the benefit of Azure for your containers is just a natural integration with all of the other things, be it security, be it identity, or databases, or whatever it might be, all in the same cloud, same area, integrated. Again, so think Azure App Service, think more for web apps and mobile apps and things like that. Container instances, once again, that provides a single pod of Hyper-V isolated containers on demand, right? So think of it as a low-level building block compared to container apps or even the AKS, right? It doesn't have a lot of the bells and whistles. It doesn't do load balancing or scale or certificates, right? So think to scale ACI to 5 container instances, you just create 5 distinct container instances and you run them. I talked about AKS already, so I won't dive too far back into that. But lastly, I do want to once again highlight where Azure Functions kind of fits in, right? So Functions itself is serverless, functions as a service solution, and it's optimized for event-driven apps. It has a lot of characteristics that are like Azure Container Apps around scale and integration, but it's optimized more for ephemeral functions. It's either code or containers, right? So functions, the programming model, it has productivity benefits, we'll say, for teams looking to trigger on events and bind to your other data sources, right? So that's really where we're looking in. Are we looking at events, binding, run the code quick and get done with it? But again, the functions programming model is available as a base container image. And again, you can either run it in functions or you can add it into somewhere else that you're running them, be it container apps or AKS or things like that. So I want to say there are many other factors that contribute to making the decision of where to run them. And that could be familiarity with them even. So a lot of times you may not be familiar with all of them, but that could help figure that out. You need to look at specific features of one or the other service that you need. You would look at integration points with other services. You would look at the security of it, if you need certain security things in place that one would provide. Obviously, we believe these can all be run securely, but if you have specific things that IT requires, they may not have them, you need to look it in. You would also look at the tiers, right? What is the standard tier? What is the premium tier of each of these? What are the costs associated with them? And what is the features that you get at those levels that you would need to implement. And keep in mind, these are not usually running these aren't running in isolation, right? So think like, oh, I know I want to run my website or my container microservices and I need to run them in containers, but that is not the full depth of what you're trying to do, right? You're trying to have this together, provide the solution, and have this website or service or something running that's going to be leveraged. So it's going to be called by other places and it's going to leverage other things in Azure, be it networking or infrastructure or whatever it might be. So you're going to need to integrate with those solutions, and how each of these integrate, how each of these are accessible and secured. That's important to know when you're kind of comparing. So kind of go back and forth between, okay, what do I need? Where does it have to integrate with? Things like that. Another thing to consider is how it fits into your DevSecOps processes, right? So how do I get this integrated? How do I scan my things? How do I secure them? How do I put them out? We call it software supply chain security, right? Is the code secured coming out of Azure DevOps or GitHub? How do I scan that before it runs? How do I make sure I'm not pushing keys out anywhere? How do I scan the containers, then put my software on and scan it again to make sure that I didn't inadvertently introduce a vulnerability somewhere? How do I know it's secure while it's running, right? And I addressed some of those things with Microsoft Defender for containers. However, thinking about that whole process end to end of where you're getting it, how you're securing it, how you're scanning it, how you're running it is going to be an important thought process as you design the system around it. So that was a lot. I've left about 10 minutes here where I'm going to wrap this up, say thank you, and then I will look to the chat for questions. And then anyone who has a question that wants to come off of mute and give the question yourself, that'd be good too.
Awesome, Tim. Thank you so much for all the valuable information. And thank you for everyone in attendance who has stuck with us this entire time. We really appreciate you and hope you got some useful information today. Do want to have a plug just really quick. We already have our next session scheduled. We're going to be talking about the custom Copilot stack, how to add intelligence into new apps or into existing applications. And so that will be at the end of next month, just after the Thanksgiving holiday. So follow us at the link in the chat.